All right, so here's how I modeled the A puzzle. Here's a board. It's a simple two-dimensional of integers of tiles where n by n is it's three by three. I'm also storing the ID, which is just an integer representation of the tiles for easy lookup later. Here's the successor function, which I call generate next states, which is just find the index of the blank tile and then check if the moves of one to the left, one up, one down, and one right are valid, i.e. within the 3x3 matrix, and then swap the index of the blank tile, which the one with the one left, right, up, down, etc. And if each one is valid, swap it, add it to the child states, and return. Okay, so here is the search algorithm skeleton. So for most of the heuristics, I use this priority queue skeleton code, which is create an interval heap, which is a priority queue using whatever compare you pass in. So I'll talk more about that later. You initialize the priority queue with a root node. You initialize some repeated state checking tools. Previously expanded is nodes that you pop off the queue. IDs to node is just nodes that you've seen at all before. So this is used for nodes within the queue. And then here's some logging information. So while the queue has stuff in it, extract the minimum based on the selected comparer, update your nodes popped off the queue, and also your tracking information. So now you've expanded this state. If this one is in the end state, which just checks it against the end board, then handle the end state and break out of the while loop. All this does is print the appropriate path and logging information to the screen. Otherwise, continue to generate the next states. For each child, check if you have previously popped it off the queue. If not, then get the heuristic score, create a new child node, which keeps track of the child board that you're at, the parent, so you can trace the path, the cost to get to the parent plus the cost of this child, which is the total cost to get to this node, the depth, which is the parent depth plus 1, and the heuristic cost, which you just calculated. Now use this thing called a priority queue handle to check what's already in the queue. So if this IDs to node contains the key that is the child ID, then we've already seen this node somewhere. And since we haven't expanded this node, because otherwise we wouldn't be in this if loop, then it must be in the queue still. So check the cost that's in the queue, and if the child that we just created, that its cost is less than the cost that's in the queue, then use this handle to quickly replace what's in the queue with the current child node and update the child node handle. So for future reference, if you need to update it again, you can. If the cost that you just calculated is greater than what's already in the queue, then don't do anything with it. Otherwise, if IDs to node doesn't contain this key, then we've never seen this child before and we just need to add it. This is just for logging information, but this is basically the while loop structure. Now the heuristic that I designed, each of these heuristics implement this interface heuristic, which just has the requirement that the heuristic implements this get heuristic score function and returns an integer. So the heuristic score is just a multiplicative heuristic plus g of n, so f of n equals g of n plus h of n, where the cost to get to the node so far is the parent cost plus the tile moved plus this multiplicative heuristic, which is just the Manhattan distance of a tile from its end state times the actual value of the tile summed up over all of the tiles. So now I'm going to show you what it looks like when you actually run the code. The nice thing about having this skeleton code is that for each different algorithm, I can just create a new heuristic that I want and pass it into the skeleton code. So when I hit start, I'm going to enter what phase I want it to be at, which prints you the initial state, and then you can give it your option. So I want a star 3 because that's a fun mystery heuristic, and it prints out the path and the logging information, and then you press the key to exit. There you go.